All right. Good morning, everybody. How are you? Woo! All right. Our next speaker is going to be discussing the development and support of Nagios plugins for e-sensors. So how about a warm welcome for Arun Ramanathan.
Good morning, and I'm pleased to welcome you to Environment Monitoring with Nagios. Before I proceed further, I would like to thank the user community for web sensor and our products, and a special thanks to Ethan and the Nagios team for supporting us since 2003. It has been a pleasure working with you guys. Thank you. And let's proceed with the presentation. It's Environment Monitoring with Nagios. In this presentation, I would be talking about the list of sensors that are involved in environment monitoring, particularly towards the IT sector, because we have more an IT sector-based crowd. And the methods of data acquisition. People generally wonder how a temperature monitoring is possible with, or a humidity or any other monitoring is possible with a network monitoring software. I talk about the methods how you transport the data from the sensor to the Nagios server, then some of our products, how they evolve based on our customer needs, and some more applications with Nagios, the system architecture, and future goals, what we intend to do. Coming to environment monitoring, these are some of the sensors which I would like to concentrate on, particularly the temperature, humidity, and illumination. When we talk about environment, we are constantly interacting with these parameters or these physical parameters around us, and they influence us to quite an extent, and we don't even realize it. So I'm going to talk about the need for this environment monitoring in the later slides. And if you consider an IT sector, you would have more of temperature, humidity, and illumination, and other electrical energy which are measured. And we are constantly using this in our day-to-day life. But if you consider more an industrial sector, we would have some of the sensors like air quality, level detection, proximity, number of people in the factory going in and out, so on, acoustics and pressure, so on, would be more important. And now I would discuss how to transfer the data from the sensor. Two simple ways, just wired and the wireless methods. The wired methods, when we talk of the serial port, which is the RS-232, better known as the COM port, then RS-433, 432 standards are also there. And the USB is also well known, and Ethernet is something which we all know about and we like it. And the problem with serial port and USB is they cannot run to a very great length. So that is one of the issue. And Ethernet is already a well-established, it blends into our internet and our complete computer network, so it makes it a lot easy, and I'm going to focus more on the Ethernet-based network sensors. And speaking of wireless, there's a very wide divergence of wireless networks available. So the 433 megahertz subnetwork access protocol, SNAP, is something which is used in nodes which are deployed in several locations, and they can use to be talked to a central gateway, which would be a Ethernet or a Wi-Fi based gateway. And each node would be collecting temperature, humidity, illumination, or water level, and could be any parameter, maybe analog or digital parameters too. And speaking of Zigbee network, Zigbee is a mesh network, that's the advantage. And when I talk of mesh network, if you want to transfer data from point A to point C, so A being the sensor and C being the Nagios server, what happens is A can directly talk to C through the wireless medium, and Zigbee works at 2.4 gigahertz. Or A can talk to C through B also. So A sends the data and B receives it, and B repeats it again and goes to C. So there are many redundant paths for the data transfer. This makes the communication more reliable and reduces error rate. Of course, by doing so, you have better data reliability, but you lose your data speed. You lose efficiency of data speed. So any sensor parameter is going to be not more than 3 or 4 digits, maybe 4 kilobytes of data. It wouldn't take much time, much network latency wouldn't be required for this. And 6LoWPAN is something similar to Zigbee. It has the Zigbee base, but it has an IPv6 addressing. That is the basic advantage of 6LoWPAN-based sensors. The advantage with that is in the future, we are going to have more of IPv6-based sensors, and So 6LoWPAN would be the way to go if we have to develop some new sensors for the future. And Bluetooth is, we all are familiar with it, and it is merely used for peer-to-peer, any prototyping and test applications you want, just you have one particular place to monitor, that would be useful. And with the Wi-Fi, we all love it, we all use it all over, and it's a well-known standard. We use the 82.11b in most of our products because although you may wonder when G and N are there, why we still stick to B. The reason is B takes less power, so if you want a battery-operated application, it holds a better job for if you want to use B. And cellular networks can be used in places where you can't run wires and the Wi-Fi is not available, and remote monitoring is required in certain applications. We had customers who wanted to monitor the traffic going through a bridge or somewhere, and we had to talk to them through these CDMA-based modems. It was just a concept which we provided what could be done. And speaking of our products, what we have, the EMO1 and EMO8 are known as the web sensor. They basically, EMO1B was the first product which we developed, and it proved it well for over the years. And it has basically monitors temperature, humidity, and illumination. And we have additional parameters can be monitored by the EMO1. That was one of the reasons why it always made it to the server rooms, because it can monitor thermistor, battery voltage, contact closure, and water flooding too. If you want to configure your EMO1 with Nagios, you would be able to monitor temperature, humidity, and illumination at the sensor end, and you can have a probe attached to it for doing thermistor or battery voltage monitoring. When I speak of battery voltage, it's like monitoring the UPS batteries, which is a DC voltage. So many of you us want to know that none of the UPS systems which were used in the early 2000s had the ability to monitor the voltage and report it to the computer. So that by using this, we could cross-check and see how good the battery is. If it is on load, what's the voltage? Is it dropping? Or things such sort of reports can be generated. Contact closure is another important feature. It does help in certain security-based application. All you have to do is you have to crank up the polling interval for Nagios to keep checking every 10 seconds and see if any contact closure is alert is sent, so that you get an immediate alert as soon as the event occurs. Contact closure is basically you have some kind of a read switch which is magnetically actuated, and you can have it set up on a door or in a server room. You want to be notified if somebody enters the room, or somebody leaves the door open or something. Any contact, it's just an on-off switch which can be actuated, and Nagios can sense it. Water flooding is another important application which many people were interested in. When you have extreme weather conditions and like condensing temperatures, you would have a lot of water condensate form near the AC ducts, and this could really hurt if it can cause any short circuit. You don't want that to happen in your server room or something, preferably not on a weekend. And when we developed the battery voltage monitor, there were several requests coming to us, like asking us whether we could make something to monitor the AC line, and that's what led us to develop the power meter. We have been developing and researching them for years, and we have finally perfected it, and we have a good design. The power meter PM21 is something which plugs into your wall outlet, and it has the ability to monitor voltage, current, true power, and a lot of other power quality parameters. When I speak of power quality parameters, like in certain European countries, they have certain limitation on the power factor of the load which you're going to use. How much of like lead and lag, the current and the voltage will be in phase or not in phase, depending upon the inductive or a capacitive load. And most of the computer systems use a SMPS-based power supply. It's a switching power supply. That causes a lot of noise into the line. And if you're in an educational institution or in a medical organization, you have these computer systems installed, you don't want to kick in these noise going into these sensitive monitoring equipments. So the power meter helps in monitoring this thing. Even better, it has a built-in relay. So Nagios would no longer be just a monitoring device. If you use it with a power meter, you can use it even to control a load, that is turn on or off a device using the power meter. This could be a space heater, could be a table lamp, it could be anything which you can plug into the wall outlet. Then we built the three-phase power meter, which is still in the prototype stage, but we have it working. We have been testing it with Nagios too. It works great. And that monitors the current voltage and these power quality parameters.